So I heard the dog invading and jumped the gun at ending the last video too soon. I want to add one more important thing. It's the diatomic elements. So when we talk about things in their elemental form, we normally mean, you know, one lithium or one magnesium. We can talk about these guys as individual components. We can't talk about individual components when we're talking about nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and astatine, although this guy exists it has such a short lifetime that nobody ever really talks about him or her. So our diatomics start here and go here. And why? Well, if you think about it, there's short one electron, and if we want 8, then it makes sense these two can go to, or all of these can bond with a counterpart, another atom just like it, and each can complete the octet or the valence shell of the other. So they can do some electron sharing, and then they become very stable. So they will bond with like atoms, so themselves. So this guy by diatomic means we write it I2, Br2, Cl2, F2, O2, and N2. And then all the way over here, and it's different from the octet rule, so I'm not going to say anything else about it, then yes, this is stable for hydrogen. So it doesn't need 8, it's quite content with 2, and it does all sorts of cool chemistry regardless. So those are our diatomics, and there are several songs to try to remember who's a diatomic and who's not. But if you just think about it in terms of how easily these guys go together and complete octets, then hopefully you don't need to memorize anything. You can look over here at your halogens and say, oh yeah, I remember, those are all diatomics. You'll remember oxygen is. Nitrogen might be the only one that you kind of have to force into the brain somehow to make sense of. But you don't need to memorize a darn thing. There you go, diatomics.